Okay, now begins our technical demo session. So prepare your EM. Prepare your EM if you want to follow along. We will resume the previous donation project. As you can see here, I did some more work here, and as I dig more, I had better discoveries. So I talk about some of them, selectively, step by step. First thing to talk about is something I think I forgot to mention or forgot to emphasize. When I did the neural network and the neural network following the stepwise regression last time, so I want to emphasize again, or emphasize it. When you train a neural network, two things that you always remember to do by following the tutorial. One is going to the optimization and deactivate or disable the initial training, right? And you know how to do it. Another is make sure that you change whatever model selection criteria is that is appropriate to the problem. And here for predicting donors, we stick to the misclassification criteria to select the best model. So there are two things that I did that's great. And another thing to do to make sure that you remember to do is here, standardization of the variables. It's by default it's no. So it does subtle influence the results, although not not clearly. If your data set has has inputs that are drastically different in scales, like some variables in scale of 0 to 1, so digital numbers point something, but another variable with scales of 10,000, then without standardizing the variables, the model may suffer from conversion to the optimal solution. It may take much longer to converge because of the sensitivity created by the scales. But in some other cases, it may not have a huge influence. But I would suggest you always standardize the variables. It does no harm, but it brings some benefits sometimes. So that's good. Increase the flexibility. For this part, I'll follow the tutorial on the PDF. It's the part 3, page 35. I'll simply modify this neural network. Something I didn't do, but was included in the previous PDF as well, is you can go into optimization again, and you can increase the maximum number of iterations that the model converge. If you look through the results report from neural networks, it said convergence didn't achieve, or something like that, wasn't successful, because in 50 iterations the algorithm didn't converge. It doesn't mean it didn't run or it sort of broke. It did broke, but from a computing point of view, it didn't reach a stable set of coefficients, and there are 250 coefficients. It's a large number of coefficients. Those coefficients, some of them still loose. They're still changing by a large, significant scale from the computing standpoint. So it wasn't stable. But again, it doesn't preclude from being able to select the best model in terms of overfitting, in terms of predictive generalizability. So I think the best model was selected at 16 or something iterations, so well before the 50 maximum. But for in dealing with bigger data sets and more complex problems, you may want to loosen up the maximal iterations and allow it to go up to 100 or 200. But I should warn you that the larger the number, the longer it will take for the software to respond. So that and that was actually one of the techniques that you can use to increase the flexibility of the model. Another tool that another option to increase the flexibility is to make the network bigger, by increasing the number of neurons in the hidden layer. And also you can tweak other parameters here. So the obvious option is to increase the number of hidden units, which is the hidden neurons. And it doesn't necessarily improve the model, but it just allows more possibilities. And that's the only thing that the tutorial did. I'll just change it and see, and make a quick run. So far, I have like 1, 2, 3, 4, 5, 6, 7, 8, 9 models. This neural network stands at the second top, so it's still good. It uses a lot of inputs, but somehow the problem is complex enough to benefit from the larger number of inputs. But I only had 3 units, so let's see if bumping up the number of units will increase its rank. Let me make sure that I change this one instead of the others. Okay, great. So let's see. Yeah. It actually, yeah. So before what I changed, I used the default 3 units, and that neural network, the original neural network, ranked at the second based on validation misclassification. After I changed it to 6, its performance even better, so it beats all the others. Take a look at the selection, the validation misclassification of your models and see where your model would rank based on a visual comparison. All of these models, instead of other than the neural network, all benefited from another advanced sort of input selection algorithm, Lars and Lasso, all of these benefited from that, and a neural network follows that. This one is Lars directly. So they have somehow, a better what's so-called regularization component of the algorithm that, that better manages the number of inputs. I'll talk about that if we have more time, either today or next time.
So the one where we did neural network after stepwise regressions is performed not really well.
Not very well.
It's
Mostly
like the
because
third protocol.
yeah, mostly because the stepwise kind of limited the inputs too strictly, and the neural network does not have enough number of inputs. And if you look at the do we have it? No. Degrees of freedom is the number of coefficients. That model has 500 coefficients there. The other ones have very few. The neural network after stepwise only has 31, so it doesn't have enough power driving the train, driving the network. So for this problem, at least, it benefits from more inputs and a bigger network. Okay, I've just enough time to do an AutoNeural. And I didn't talk about this before, and it has created some confusions before in previous semesters. So AutoNeural is like this. Wait, no. Somewhere. The first one. So AutoNeural is not similar to the neural network. You would hope that AutoNeural does everything for you. It doesn't. You're in for much surprise. What it does is it's sort of like a stepwise regression, but it doesn't choose inputs for you. It simply keeps all the inputs that you feed in. But it started from one unit, hit a unit, and increased the unit. And under each unit, under each topology, 1 unit, 2 unit, 3 units, and so on. Under each topology, it chooses the best model of all the iterations simply. So it's quite simple, automatic process. And typically it stops at 1. So let's try one. I will not even connect that. There's some, I think, there's some properties to change. Let's see. Train action. Train action is search. Number of hidden units starts from 1. Tolerance low. Direct. No. Normal. So all of these settings are increasing the flexibility of the starting point or the termination point, allowing the model to search a wider space for possible solutions. Sign, no. Okay. It actually stops at 2. So in previous semesters when I didn't talk about it, just bear with me 1 minute. When I didn't talk about it, and when the students, tried it AutoNeural because the book talked about it, they tried it, but without looking closely at the tutorial. They look at this graph and they it doesn't look at all as our overfitting. At least you have a longer trace, and you can see the bifurcating, and it kind of it just plateaus. So without knowing more, you cannot work with it. So this AutoNeural is not as helpful as a direct solution, but it guides you somehow, or give you a hint of what might be the optimal number of hidden units that you should choose. But looking at this, and after training all the other models, I kind of don't trust it, because it stops at 2. It kind of suggests that you only need 2 units for this problem, but actually you need more. So, but you can try a network with only 2 units, and see, try different inputs, and see if it at all will compete with the other more complex networks.
When we say units, we mean hidden layers.
Hidden units.
Units.
There's only 1 layer.
Okay.
1 layer, but more circles. Yeah. And so let's call it a day. We'll see you next week. No homework this week. Yeah, questions?
When you said describe the topology, what are you looking for?
Topology is how many layers, you should know, without looking at the results, you know, how many neurons or units in each layer. And to know the hidden units, you can simply look at the specification, the network specification. The default is read. To get the number of output units, by knowing what the target variable is, you know the answer. In other words, the number of the tricky part is the number of neurons. During last video last week, I kind of talked about how to work with the results and calculate. So we're going to take another look. Basically, it's a painful process. You have to look at the coefficient results, and then the number, and divide something. So rewatch it, and if you have other questions, let me know. Thank you.
Thank you.
Thank you.
Have a good night.
Please return the feedback if you can.